a very important topic, SD-WAN VPNs. Right. So first of all, VPN is nothing but a VRF. Right. Virtual routing and forwarding instance. Clear? So in case of SD-WAN, we are actually using the keyword VPN instead of VRF. Fine. So the first sort of VPN that we will see in SD-WAN is VPN 0. VPN 0 is basically called transport VPN. Right? What we call it? Transport VPN. What do you mean by transport VPN? Interfaces which are going to connect to the WAN devices are configured to be member of this VPN. So whether you have MPLS connectivity or you have internet connectivity or you have 4G or LTE connectivity, any type of WAN service you have to connect those interfaces to my WAN edge device, and you have to configure those interfaces to be a part of which VPN? Transport VPN. Transport VPN is used to build the underlay connectivity, right? So VPN 0 number is reserved for which VPN? Transport VPN, right? Second, we have VPN 12511 and 5132655535. We call them service side VPN. All interfaces which are going to connect to LAN side are configured to be member of this VPN, right? Next, VPN 512. This is called management VPN, right? So this VPN is there to provide out of band management to your SD-WAN fabric, right? So I have shown you on your vManage, your vBond, your vSmart, and on your vEdges, we have a separate management port that can be used for out of band management, right? So VPN 512 is the management, for the management aspect, right? If you want to manage the devices, manage the devices means taking the GUI, CLI, whatever you want to take, right? So these are the two most important VPNs. First one is transport VPN and second one is the service side VPN, right? So every interface that is connected to the WAN devices will be part of the transport VPN, and all the interfaces that are going to connect to the LAN side are called service side VPNs. Let's see a picture to better understand it. Now guys, just be with me. I am responsible here to make you understand everything. So this is your WAN edge device, right? So we have which interface? G0 by 0, 0 by 1. These are connected to my WAN devices. Let's say G0 by 0 is connected to internet, 0 by 1 is connected to the MPLS, right? So these interfaces will be member of which VPN? VPN 0. Clear? Second, what is the use of VPN 0? To communicate with the controllers. Which controllers? vManage, vBond, vSmart, right? After that, what is the use? To communicate with other vEdges. So all this communication is going to take place from VPN 0, right? Now second, what is management VPN? So management VPN is there to provide the out of band management, right? So I'm not explaining this here, right? So maybe in future we will discuss, but this is not an important aspect. Second is service side VPN. So let's say you also have two more interfaces, 0 by 2 and 0 by 3. So you configure 0 by 2 to be member of VPN 5, 0 by 3 to be member of VPN 10. On VPN 5 you are running, only have a directly connected network. On VPN 10 you are running dynamic routing, right? So all the interfaces which are going to connect to the LAN side will be part of the service side VPN, or we call them service VPNs, right? Now how this thing will work in a real picture? Now look here, very interesting point guys, and this is the last you can say last topic that we are going to discuss for the day. I will not make it difficult for you. Now try to understand my point. Just a minute. How this thing will look in a bigger picture. Very interesting guys. Now you will be able to understand what I was speaking from a very long time. Let's say this is your VH1, this is your VH2. These are two different sites, right? I'm not here talking about any control plane. We are only focusing here on the data plane. Look here. So I have an interface connected to my public network or to a WAN edge device. This interface is going to be member of which VPN 0, right? This interface is going to be member of which VPN 0. Now the LAN interfaces, let's say this is interface 1, interface 2, interface 3. So all these three interfaces are member of different VPNs. So how many service VPNs we have? 3. Fine. Service VPN 5, 10 and 33. On the other end also 5, 10 and 33. Now let's say 5 want to communicate with 5. So 5 will send the traffic. Traffic will be passed from the WAN network to the other VH. From VPN 10 to VPN 10, VPN 33 to VPN 33. So same service VPNs will communicate with each other by default, right? So if you ask me, Piyush, whether VPN 5 will communicate with VPN 10, no. What do you mean by VPN? VPN means VRF. VRF means we are virtually dividing the routing table of router, right? So if we are dividing the routing table, why I want them to communicate? But I'm not saying it is not possible. If you want to do it, you can do it by changing the by default behavior, right? But by default, different VPNs will not communicate. So now you have an idea. What is that idea? That if I have multiple VHs, they are connected by a WAN, they are connected by some WAN, they can communicate with each other. First thing, that the WAN side will always be part of VPN 0. The LAN side should be part of any service VPN, VPN 1 to 511 from 513 to 65535. If you want to make that communication by default, they should be member of same service VPN, right? If they are member of different service VPN, they will not communicate. Now the point here is how this VH2 will get to know that whether the traffic belongs to VPN 5, VPN 10 or VPN 33. So guys, all the traffic will be tagged with this VPN number. With VPN number to provide the segmentation. Segmentation means VH2 will get to know that this particular traffic belongs to this particular VPN. Right guys? Any problem you can ask. Okay, let me clear this picture more. Let's bring it here. Look guys, now this picture is making the things more clear. This is one WAN edge, second WAN edge, third WAN edge. All are connected to internet. So this is my WAN, right? So all these WAN networks are member of which VPN? VPN 0, right? Clear? So over VPN 0, they will be reaching the controller. It means all the routing information will be exchanged from the controller. Routing information, right? From the controller. Once the routing information is exchanged, now my LAN sites, means service VPNs, will be able to communicate with each other. Now see here, I told you this traffic will be encapsulated by whom? By IPsec. In IPsec, ESP performs the encryption and authentication functions. So guys, you can see, let's say this is your data that you are trying to send. So you can see a VPN tag. So VPN tag is there. Now you will say, Piyush, here it is 5 or 10. Guys, this is the size. VPN tag will be of 4 bytes, right? And VPN tag will consist of a numeric value which will define this traffic belongs to which VPN, right? So guys, this particular thing is called VPN segmentation, right? Any particular doubt in this? Guys, feel free to ask, right? So we have different VPNs, VPN 5, VPN 10, same VPNs will communicate with each other, right? Service side VPN simply means on your VH devices, wherever you will connect your LAN interface, right? That particular interface will be part of some service VPN, right? So all your LAN side will be part of service VPN. Now guys, you know what is the beauty of this SD-WAN solution? Now look here. Let's say this is your WAN VH1, this is your VH2, right? And I already told you the WAN interfaces will be member of which VPN, VPN 0, right? Now here you have VPN 1 also. So what is VPN 1? VPN 1 will be the service side VPN. This is also VPN 1. VPN 1 will be the service side VPN. By default, what we know, different VRFs will not communicate, but here it is not the case. So this is the beauty of SD-WAN, that all the traffic that is coming from VPN 1 will automatically enter into VPN 0 and pass to the other VH. And similar cases with the reply. And this all process will be automatic. You don't have to do anything, right? So all the service VPNs which will exist here, service VPN means my LAN side VPNs, which are existing here on the VH device, will be communicating with the other service side VPNs, but the same service side VPNs, 1 with 1, 2 with 2, 3 with 3, 4 with 4, right? And all the traffic is passed through which VPN, VPN 0. Clear? So someone was asking about what is service VPN. Service VPN just means the LAN side of the SD-WAN fabric. Okay, let's say you want to connect them one by one like this. No, all these three interfaces can be member of same service VPN, right? Right. Now, let's say you want VPN segmentation. You want the network behind this switch can only communicate with the remote network that is behind some switch. So you can create a separate VPN for it. Let's say VPN 5, VPN 5, and this is VPN 10, right? So this particular VPN 10 will only communicate with whom? VPN 10, not with VPN 5, right? I can give you an example like this also. Let's say you have these VHs. These are your switches. I'm not using multiple switches. I will use multiple links, right? Now let's say this is network 1, 2, 3. This is network 4, 5, 6, right? And they are member of VPN A. I'm using, okay. Let me use these as VPN number 1, 2, 3, 1, 2, 3, right? 6. So that network 1 will communicate with 4, 2 will communicate with 5, 3 will communicate with 6. Are you clear with this? All of you? Guys, please answer. 1 with 4, 2 with 5, 3 with 6, right? Because they are member of same service VPNs, right? So the VPN which is present on the WAN side is called the transport VPN. The VPN which is present on the LAN side is called service VPN, right? So now you are clear about one thing. See, like I told you, this is a new way of doing the things. So it's not like that you will be able to digest it in the first go. It will take some time, right? So just try to picturize things in your mind. How you gonna picturize them? First of all, relax. Second thing, Start thinking about it. What are the problems with traditional WAN? Okay, I'm good with the problems. Second, who is gonna address these problems? SD-WAN is gonna address these problems. Now, how? Okay, SD-WAN is going to do something. First thing it is gonna do, it is providing us the centralized management. How it is providing us the centralized management? With the help of vManage. After that, who will take care of the routing in SD-WAN? vSmart is taking care of routing. Third thing, who is taking care of authentication? vBond is taking care of authentication. What are vEdges? vEdges are the devices which are installed on all the physical locations, all the remote locations, data centers, headquarters that are going to pass the data plane traffic, right? What are the different SD-WAN components? We have orchestration plane, we have control plane, data plane, management plane. Orchestration plane is handled by vBond, management plane is handled by vManage, control plane is handled by vSmart, and data plane is handled by vEdges, right? Then just go through the working of each and every device like I told you. After that, try to make a picture, try to make a topology in your mind, how these different sites will be connecting, right? So you can see this is my cloud where all my controllers are hosted and all sites have vEdge installed. Now at the end of the day, my task is to make the communication possible between these vEdges, right? So these vEdges are going to communicate with the controllers also, but just for the control plane information, just for the authentication purpose, not for the data plane, right? So let's say I'm on R13. Let me go to R13. Show IP interface brief, right? And the IP is 10.3.13.13. 10.3.13.13 is IP of E0 by 0. That is very good. Show IP route. Here I have a loopback 10.1.0.16. Now guys, what I'm going to do, don't think too much, right? What I'm showing you, just concentrate here. I'm tracing one of the IP address which is existing on switch 16, that is in my data center, from a remote site, right? And the SD-WAN is already configured and working here. Now I want to show you a very interesting thing. So traffic from iOS 13 device is going to 10.3.13.3. This is the IP address of vEdge GE0 by 2. That is the service side interface, right? After that, you can see IP 10.2.0.1. 10.2.0.1 is the IP address of, I think, vEdge2, right? vEdge2 service interface, service side interface, right? So what I'm trying to tell you, so you have noticed that from a long time I'm using the word fabric, SD-WAN fabric, SD-WAN fabric. What do you mean by SD-WAN fabric? SD-WAN fabric means think of all these devices as a single device, right? vEdge 1, 2, 3, these are physically different devices. But to explain you the meaning of fabric, try to understand it. This is my SD-WAN fabric, right? SD-WAN fabric means anything I am sending into this will exit out and I will not be able to see what is in between. So I will not be able to see any IPs, any ISPs, anything, right? You can see from the trace, from R13 I am trying to reach a loopback on R16, right? So traffic is entering into R13. This is our vEdge3 IP and this is vEdge2 IP, right? So traffic is coming here and going to switch 16, right? So this is what I'm trying to explain you here. That fabric means that we are connected to the same device. It will look like that both of the site, this is my DC also, and my remote site 3 also, both are connected to the same device, right? Clear? This is the meaning of the term fabric. I hope we are good, guys, right? So tomorrow we will discuss more onto this topic. I hope you will read about it, and if you have any questions you can ask. So tomorrow I will start with the onboarding process, right? Onboarding means I will tell you I will discuss about the PKI stuff. I will tell you how you will bring up vmanage, vbond, vsmart, all these things, right?